hello everyone. We are from Group 9. We'll present about the experiment 6, which is Bourdon Tube Pressure Gauge experiment. So I am the leader for this group for the experiment, which is my name is Siti Nur Antasha, and my group members are Nurul Nafisha, Pavitra, and Raven. Okay, so next. This is the content that we will present today. Okay, next. Okay, so the objective of this experiment is to calibrate the Bourdon Tube Pressure Gauge using dead weights. In Bourdon Gauge pressure calibration, we are required to compare experimental results with the actual ones. In order to calibrate the gauge pressure, we are also needed to find the error. Bourdon tube is one of the equipment to measure pressure. Before any measurement system or equipment to be used, is it compulsory to calibrate the equipment? So the equipment can be just as accurate as a working standard. To calibrate a measurement system, we have to compare its theoretical pressure with measured pressure. In this experiment, we have to calibrate the Bourdon tube pressure gauge by mounting the transducer in a closed vessel with a piston at one end called a dead weight tester. The weight tester provided were in various standard weights. So this, okay, next slide. Okay, so the experiment is conducted by inserting a piston into the cylinder, and air bubbles inside are removed by rotating or pushing the piston. When the piston is inserted in the cylinder, the pressure gauge deflects. By manipulating the weight with an increment of 0.5 kg until the total mass reached 6 kg, the data was recorded for each test by loading and unloading the weight. Okay, so for this experiment, we obtain percentage error of total mass 1.0 kg, 1.5 kg, 2.0 kg, 2.5 kg, and 6.0 kg for loading and unloading method respectively. Okay, next. I'll, okay.
Hi, I'm Pavitra. For the theory part, instrument calibration is one of the primary processes used to maintain instrument accuracy. It is the process to configuring an instrument to provide results within an acceptable range. Known weights have been applied on a dead weight calibrator to apply pressure to a fluid for checking the accuracy of readings from a pressure gauge. Many engineering applications uses the Bourdon gauge. The figure shows the simple structure of Bourdon gauge. Then the apparatus is a Bourdon gauge connected to a dead weight tester. The Bourdon gauge has a transparent dial that allows to see the working mechanism. The mechanism is a thin wall tube with an oval cross section bent into an arc. One end of the tube is held rigidly. This end admits pressure. The other end of the tube connected to a dial and pointer mechanism is free to move. When the pressure in the tube increases, it tries to straighten and so moves the pointer to an amount proportional to the pressure increase. To calibrate the gauge, add weights to platform on the dead weight tester. The weights puts a known force onto a piston. The piston has a known area, so we can calculate the pressure, and flexible tube containing water transfer the pressure to on the piston on the Bourdon tube. Add the weights in increments, recording pressure readings from the gauge at each increment. Then remove the weight and record gauge readings. By working out theoretically result, they can work out gauge error and discuss possible errors. Next page. This figure shows the simplest structure of deadweight tester. In order to obtain very accurate pressure measurements, it is essential to regularly recalibrate the gauge. This is because the tube tends to become weaker with extended use. The usual procedure is to apply a known pressure to the gauge using a device called a dead weight calibrator. The normal calibration procedure is to load the gauge for known pressures using a dead weight calibrator including a liquid of known specific gravity, which is used water as the liquid. This dead weight tester uses a simpler piston and cylinder arrangement to provide a source of pressurized liquid, which is all transmitted to the gauge. Since the true pressure of the liquid can be easily calculated, The value can be compared directly to the reading on the gauge over the complete scale range. The dead weight tester consists of a cylinder piston which is freely moved vertically in a closed-fitting cylinder. A flat a platen is attached to the piston which can be loaded with a series of accurate weights. The pressure developed in the cylinder is transmitted via a transparent tube in the gauge under test. The cylinder is mounted on a base board which is supported on leveling screws and fitted with a spirit level. Next page. So these are the equations used in this experiment. Okay, where the first equation is P equals to force over area, and the second equation is F equals to mg. F is the force applied to the liquid in the calibrated cylinder in Newton. M is the total mass including the mass of the piston in kilogram, while A is the cross-sectional area of the piston in square meter, and G is acceleration due to gravity in meter square second. The true pressure of liquid can be easily calculated using equation 1 and 2. The value can be compared directly to the reading of the gauge over the complete scale range. To obtain more precise value of the reading, average value is calculated by following equation, which is equation 3. Average value equals to first reading plus second reading divided by 2. Percentage error for this experiment can be calculated by using the following equation, which is equation 4. Percentage error equals to measured value minus actual value or modulus over actual value times 100%. That's all. Next, I pass to Nafisha.
Alright, so I am Nafisha and I'll proceed with the apparatus and procedure for this experiment. So the apparatus used in conducting this experiment is Bourdon Tube Pressure Gauge, 1 kilogram piston, and also dead weight tester that weigh 0.5 kilogram each. Next slide. So this is the procedure of this experiment. The first step is 1 kilogram piston is put into the cylinder of the Bourdon Tube Pressure Gauge. The piston is rotated in order to remove any air bubbles present. Second step, the reading on the pressure gauge is taken while there is no weight on top of the piston and after the system is stabilized as the first reading. Next, a dead weight, which is 0.5 kilogram, is placed on top of the piston and the reading on the pressure gauge is recorded. Fourth step, the weight on the piston is increased by 0.5 kilogram increment, which equals to 1 dead weight. The reading on the pressure gauge is recorded as 0.5 kilogram weight added to the piston until a total of 5 kilogram weight are added. Next, the weight are unloaded from the piston by the decrement of 0.5 kilogram. The reading on the pressure gauge is recorded every time the 0.5 kilogram weight is removed from the piston. And the last step, step 1 to 5 are repeated 3 times to get the average reading. And all the data are recorded in a table. So that's all from me. I will pass to the next presenter.
The results that we get from this experiment, so we can see that we get the percentage error of loading and unloading data respectively on the table. Okay, so next.
I'm Redan and I will explain about the discussion part. So first, percentage of relative error for the theoretical and measured experimental pressure gauge. A piston of known area is loaded by a known weight F, therefore the theoretical pressure in the cylinder is F over A, which is the unit kilonewton per meter square. A measured experimental pressure, F measured, can be obtained from the reading of Bourdon Tube Pressure Gauge. So next, this is the calculation part. Mass of piston will be 1 kilogram and cross-sectional area of the piston will be 3.1731 times 10 to the power of 94 meter square. True pressure exerted by piston is equals to total mass weight plus piston times with 9.81 times 10 to the power of negative t over area, which we got 46.4 kilonewton per meter square. Average reading of calibrated pressure, which is equals to 30 plus 31 plus 30 kilopascal over 3 times with 1 kilonewton per meter square and times 1 kilopascal, which we got 30.3 kilonewton per meter square. The percentage error, the formula for loading will be modulus of measured value minus actual value over actual value times 100%, which we got 34.7 percentage. For unloading, the formula, same formula, modulus measured value minus actual value over actual value times 100%, which we got 13%. So sample calculations are repeated for 1 kilogram, 2 kilogram, 2.45 kilogram until 6.0 kilogram of total mass. Next will be the sources of error and method to minimize error. There are a few sources of error that can be noticed during this experiment is carried out. First and foremost, when inserting the piston into the cylinder, there still might be air bubbles that not totally removed from cylinder and hose. Next, when weight is added, the dead weight pressure gauge calibrator responds slowly to change in pressure and hysteresis, which may cause friction to occur. Besides that, the apparatus is sensitive to shocks and vibrations. While conducting this experiment, little movement of apparatus or table will influence the reading to defect. Last but not the least, the source that can cause error is parallax error, which occurred while carrying out this experiment. The position of eyes are not perpendicularly to the scale of the Bourdon tube pressure gauge. To minimize the errors, there are few methods that can be used. First and foremost, we must make sure the air bubbles from cylinder and hose are totally removed. Next, rotate the piston in order to remove air bubbles inside the cylinder tube to reduce the friction and so that the more accurate pressure reading can be obtained. Besides that, while carrying out experiment, members should be more careful while loading or unloading the weights. Repeat the experiment by taking readings for 3 times to get a more accurate result. And last but not the least, to overcome parallax error, we should take several readings and calculate the average. Other than that, the reading could be taken by several people. For the next part, which is repeatability and accuracy of this equipment. Repeatability in the world of modern tube pressure gauge means essentially the same thing it means within the realm of flow meters or other measurement devices. It is a measure of how consistently the pressure gauge is in accurately repeating the same measurement of if all conditions remain the same. Accuracy is similar to repeatability. It's a little more nuanced, yet equally and independently important in determining the quality of a Bourdon tube pressure gauge. Accuracy is a measure of how effectively a pressure gauge is in repeating the upscale reading or the downscale cycle if all conditions remain the same. For example, while a pressure gauge may read correctly at 0, midpoint, and full scale during the pressure up cycle, it may read too high at the midpoint check during the pressure down cycle, while still correctly returning to 0. For the next part, I leave it to Nafisha.
So for the conclusion, this experiment aims to calibrate a Bourdon tube pressure gauge using dead weight tester. The gauge pressure is measured every time the weight is increased. By using the dead weights, the gauge pressure is recalibrated as the accuracy of the gauge is reduced over time. Based on the experiment, we can conclude that Bourdon gauge is one of the suitable instruments to measure the pressure, but the readings were not accurate as the actual value since there is percentage error calculated from the difference in the actual and experimental values. The uncertainties in this experiment could be from random and systemic error in conducting this experiment. And thus, this experiment is repeated 3 times so that we can get the average readings. That's all from us. Thank you.